session. We're going to run it in a bit of a any questions format from Radio 4. So I'll be putting questions to the floor, and I'd like to invite my panel to introduce themselves, please. Well, maybe with the exception of you, Niki, which is talking, but please go ahead.
I don't think I really need to. Thank you.
Take the mic. Okay, great.
Niki Haines, Keysight Technologies.
Bob Cockshott, Knowledge Transfer Network. We are an organisation of around 100 people. We're funded by BAEs, and we exist solely to help UK industry create wealth through innovation. We connect people across the entire supply chain. I know that sounds like pretentious business speak, but that really is what we do, from blue sky research right down to users and applications, with a view to helping UK industry make money and create jobs. As I always say on these occasions, you have already paid for us with your taxes, so please make use of us. If there's anything we can do, please get in touch.
Hi, I'm Desimone. I'm from BAE Systems Applied Intelligence. I manage strategic innovation with disruptive technologies. My background's in AI, but I've been looking at quantum technologies and quantum computing over the last few years. My division, Applied Intelligence, is a non-defense division. We focus on cybersecurity and other relevant applications in that area. So not the big, aircraft and missiles and defense. To jumpstart interest in this area for my company, I took a part-time sabbatical earlier in 2016, and I used that time to organise a couple of commercialisation workshops, particularly in two market sectors, in finance and cybersecurity, with funding and support from the KTN, from Bob and his team. And we generated a couple of reports that highlight some of the potential application areas in finance and cybersecurity, with very minimal business plans, but roadmaps for how they might develop over the next 10, 15, 20, 25 years. Those reports are available, so please see me afterwards. I'll send you a copy.
Well, my name is Susannah Jones. I'm from DSTL, and I'm part of the quantum projects that we have going on there. My role within the programme is to support the students that we supply with, the 45 students that we have in the national programme. And DSTL, as everyone already knows, is a government organisation, and we are the first port of call for science and defence in theatre. And we've had, many of you know very well that we've had the roadmap that's been developed at the very start of all of this. And we're not really industry, but we do collaborate a lot with industry and academia. So, yeah.
Okay, great. Well, if you hang on to the mic for a moment. Okay. So I'd like to put questions from the floor, please. Anyone? Yuri.
Is this on? Yeah. Question. The government has put in a substantial amount of money into a national quantum technologies program. It's been running for a couple of years. And it will be running for another couple of years. I suppose with the ultimate goal of bringing in private investment and both from VCs and corporate VCs. How do you feel a couple of years into the program that uptake is, if that's happening, and how do you measure that? Do you have any metrics that you can look at?
Okay, well, I think most people are aware that there's an annual showcase event which is put on, and I think if anyone has been going to a few of those, you'll see that the amount of people that's been attending those has gone up exponentially. So we feel, as a government perspective, we are there to stimulate very low research and to stimulate the market, and then allow industry to come in and support that. And we believe that this is definitely coming through, which has definitely been seen as well with investors such as E2V, who have invested quite a lot of their money into the market as well.
Chatting with a few quantum startups, I've chatted quite a few over the last few years, and when I was chatting with them 3 or 4 years ago, they were telling me that when they went to either angel investors or venture capitalists, they were probably asking in the range of sort of $2 to $5 million per angel investor. So maybe the total round was getting to maybe, I don't know, $15, $20 million. That's 3 or 4 years ago. Now, they're asking much larger sums. they're really talking about the 5 million to 10 million per investor. The total rounds are much more in the few tens of millions. That's just over a few years. It's a bit anecdotal, not going to name names, but I'm hearing some of those things from some of the emerging startup companies.
Yes, I strongly endorse that view that there is great uptake and interest in this. As I'm sure you know, Innovate UK runs some funding competitions. I think we're up to the third round now. The initial one was something of a gamble with hindsight. The uptake was extremely good. Innovate UK were very pleased. And the level of interest in these competitions is growing. They're getting more and more applications and very high quality applications, to the extent that there's really good stuff that can't be funded. And I think Susannah, DSTL and the funding that you've put in has had the same story, that there's been very high quality uptake. There are big industry players that are putting their own money and their own resource in there. One of them I think is public known as BT is putting money with an interest in quantum secure communication, and they see this as something that they will use internally and also market as a product. When the program first started, some of the people involved went to big banks and said, you need to take an interest in the effect that quantum computing is going to have on encryption and security. Now the banks are coming to them saying, please tell us what this is all about, we want to know. There's been a sea change in attitude. Obviously there's a lot of work to do, but I think we should be very optimistic, and as taxpayers, pleased that our money is being put to good use.
To answer your question regarding the UK, I think that Innovate UK, EPSRC and also KTN have done a great job to promote the technologies, to promote the possibility of actually gaining money. They've put a lot of documents and help together to help us be more successful in applications and understand what they're doing, and I think that's great. From a European perspective, I have to highlight the Quantum Manifesto, which is €1 billion over the next 3 to 5 years, where my biggest concern is what does that mean for the UK and for funding activities in the UK with the current political and decision, I guess, the Brexit, right? And I have concerns as well regarding some of the activities that are going on in the US that might have some impact, whether it be on import, export, people working together and collaborating. Those are the concerns that I have for this market right now. But I think that the UK have done a fantastic job, and I was pleased to see an increased bump up in the investment for the last round, which was due today at 12, I think. Yep. Okay.
I think you have a lot of emails waiting for you, Bob, when you get back in for the submission today. But another question is Tim.
Chris gave a really nice discussion at the end of the kind of series on quantum key distribution, quantum signature distribution, and so on. So I've got 2 questions really to pick up on: the security element that was discussed this afternoon, and then the funding element that you just discussed. So the first is, who should be the customer for security, quantum-based security? Is it banks? Are we the customer? Is it the infrastructure provider? Who's going to pay for it? We might all use it, but who should pay for it? And the second question is, what should the UK do next, given that we're sort of halfway through £250 million worth of investment? There's €1 billion or $1 billion coming down the track. Everybody's talked a lot about how investment is ramping up globally. What should the UK government's response to that be? Because they're going to need to think about it now to put it on the table for 2 years' time, 3 years' time.
So for education and research in the UK, the government is paying 1.7 GDP versus an average of other countries of, I think it was across all countries, 2.4. And there are countries like China, Korea, and I can't remember the last country that are around 3.1%. So even though there is a big investment, I also see that there aren't as many papers or as many patents filed for quantum technologies here in the UK as for other countries. I know that we're very small here, but generally speaking, obviously we want more money for quantum technologies. But it's very clear. I mean, there was a report. I don't know whether you saw that. I can send the link around if you're interested, from The Economist, that looked at the investment buckets per country based on 2015 and also the publications 2015-16 and the number of patents. And it's pretty scary to see how far we are behind here. There are other countries, obviously, in the European Union as well, that are a little bit behind. Does that answer any of your question?
I think you had a specific question about who the customer is. The UK programme is not going to be sustained by the taxpayer. The whole point is to create a flourishing business. People have talked about a £1 billion per year business with some very large numbers for the future beyond that, even rivaling the semiconductor industry as it is today. The people that will pay for the security are the people that use it now, so I can see that there will be service providers that provide secure facilities, which you can buy now, to have your stuff transported, your data transported around the country securely. So I think, in a sense, we're all the customers, because when you use your ATM card in a bank, then you're using secure channels, and part of what you pay to the bank goes to that security, and that will continue, and we'll switch over to quantum techniques as they become essential in future.
Less optimistic view I'll have, which is industry and end user companies are not going to want to pay for all that security. They're going to require that government puts some investment. They'll pay for some of it, but they're not going to do it on their own. If we relied on companies to pay for all of that, I think we'd wait for a few more years. So I think pump priming from government for some of those major programs, major initiatives, is going to be absolutely key. And then industry will come in, and some of those service providers who will see an opportunity to get ahead of the market. At the moment, some of the things you're talking about, it's early adopters who are going to be the users of that and pay for it. The biggest challenge is what's always called crossing the chasm, going from the early adopters and users to the early majority and the late majority. Crossing that chasm is going to be quite difficult. That's where the government money is going to be essential in helping to reduce the risks for some of those major corporations and get into this area. So I come from BAE Systems, big organisation. We're not putting major money into this at this stage. We're still waiting on the fence. We're putting small amounts of money, doing interesting experimentation, but we're not quite at the stage where we see we would put major pounds to deliver a big system solution yet. I hope it'll change, but we'll see.
Well, I can only really discuss this from the defence perspective, and as always, securing information will always be at the top of our agenda. However, I'm going to echo some of the things that have been said here, that at present time, QKD, especially with Free Space QKD from satellite down to ground, there's still a lot of research that is going on. In response to who's going to be paying for this, well, as I said, the government is always going to be interested in this. So, you know, we sponsor CDEs, we sponsor PhDs in this area, so there will always be continuing input from the government. But I do believe it will be the end user that will eventually be, you know, the person who forks out to secure their information.
So just add on that from perhaps the QTEC perspective, and it's something that we explored at Cranfield about the market and who will end up supporting this. And something that emerged from that is, at least in the short term, a number of small startup businesses have a large opportunity to diffuse into smaller areas of the market or niche markets. So great, you've got these big killer applications, quantum computing, things like that, they're game changers. But for the most part, things that will sustain and absorb the talent that's coming out of the training programs throughout the UK programme and indeed globally are going to be smaller things that can be applied perhaps the high technology areas that can do things better, a faster processor, a better single photon detector, something like that, and at least at the beginning building up those scientific tools before those really large applications come along. So hopefully these smaller businesses will be able to absorb the scientific talent and build up that infrastructure that can follow on thereafter. And that's hopefully where the initial investment will come, and then it will be self-sustaining thereafter, with businesses being started up. So, okay, great. Chris?
It started out as a question for Roberto, but probably everybody can say something. I was at one of these workshops and it was a lot of fun. I wondered from your side, any lessons learned from wrangling with the academic community that was there, and maybe some advice for academics that want to engage with commercialization more effectively?
Which workshops are you referring to?
I think I was at cybersecurity. It was a DSTL. I forget who sponsored it.
Yeah, it was.
There you go.
I'll start
You
off.
can
Yeah.
start.
So yeah, this was one of those workshops. Did you come to the cybersecurity one? Yeah. So this was commercialization of quantum technologies and cybersecurity, mostly emphasising quantum communications and quantum computing, less so the quantum sensing, and not really the quantum enhanced imaging. So about academics, very good, because the interactions with the academics was great, because the workshops had a mixture of people. We had 30 people. There were 8 to 10 people from key cybersecurity end user community, then 10 to 12 quantum specialists, I think it was about 4 quantum academics and 4 quantum startup companies or industry players, and then we had people from funding agencies. And the whole day was to try and identify a whole host of interesting applications of quantum technology for cybersecurity. I think in that one we looked at, I think it was 30 to 40 initial applications through brainstorming, and then we whittled it down to 8. And in the finance one, we had 75. So this is interesting. In the finance area, there was a lot more ideas came out that were more compelling than some of the cybersecurity ones, because there is more money that's going into exploring those startups in the finance area. And so we had 4 quantum startups that came to that. So that was quite interesting. But the academics, actually, I would say, very good input into the whole workshops. In particular, what we wanted to identify from the academics was, are some of these applications that we're identifying, can they truly be enhanced by quantum technologies, or are some of them actually classical ones? So it was important for the academics to say, no, that problem's not meaty enough. It's not meaty enough for quantum technology. You're not really going to benefit. You're not going to benefit from quantum in that area, and helped greatly in sort of de-risking and identifying what was very relevant in those areas. Does that help? I don't know if anyone, because it's a very specific question.
Well, any advice for academics to engage with industry?
Yeah.
Well, as you know, DSTL engages with lots of academics. I mean, our 45 PhD students are spread across, I think it's 12 universities, but we do lots of work with other universities as well. And we base all of our research, well, not all of our research, but the majority of our research with academics, and we have a very good working relationship with them. And that's how we see things going forward in the future as well.
No, I don't have anything to add to that. Our experience has been very good. It's been a two-way dialogue. The UK programme is very clear in the way it's constructed. It is not about research, it's about commercialisation. The academics clearly understand that, and are very happy to listen to potential users about what they want, rather than what the research is leading to immediately, to tune the research to what the users are going to need. It's not always obvious what the market application is going to be, and our experience has been that the academics have been very flexible and fully bought into the spirit of the programme.
Okay, great. And just another thing, in a formal role, I saw a lot of academic interaction with industry, and I would say that if you're going to ask for a letter of support with a company or something like that, do make sure that it's genuinely collaborative, rather than just, this is a very small thing, rather than just asking for money, because that never goes over well with them, just to the academic community there. So, more questions from the floor, please. Yes.
So I have several questions I want to ask. Start with simple ones. What is quantum technology?
Yep.
So I've thought about this long and hard, and I believe that quantum science and quantum technology are two different things. And I believe that we're in the realm at the moment where we have quantum science with classical technology. And I believe that quantum technology is the decrease of classical mechanisms within your system. That is what quantum technology is to me.
So I'm not going to answer what it is. What does it mean to maybe, I don't know, my industry, maybe industries like mine. So we hope that the quantum technology will allow us to either do more things than we can do now. So as an example, my company has I don't know how much we spend, but we have a supercomputer up in Wharton that we use, this is conventional, to help design aircraft, airframes, and to put new things on it and make sure it doesn't compromise the overall architect, the overall system itself. What we're highlighting is there's an opportunity to make use of a quantum coprocessor, part of a hybrid system, to help, let's say we're trying to put an antenna on an aircraft and want to make sure it doesn't compromise it. Should it be one antenna? And where should it go? Should it be one? Should it be three? Should it be five? Jumping to the conclusion of what that number should be and roughly where it should be could be something that a quantum processor might help identify and optimize, but you still need the supercomputer to confirm, having put it there, that it definitely doesn't compromise the rest of the system. You don't need a quantum processor for that. You need a conventional processor to convince the auditors, the certifiers, that actually it will not compromise the system. So my company is probably more interested in hybrid quantum classical solutions at this stage rather than a fully quantum solution. So we're probably not going to get the real benefits of some of the quantum technologies, but it might be a way of de-risking the introduction of some of those quantum technologies in some of today's solutions.
I think the way Innovate UK are looking at it is that it's anything that exploits properties like superposition and entanglement. You could argue that almost everything we do operates at a quantum level, so it's a fairly fatuous definition, but some of this stuff has been known about for decades, but now with the ability to manipulate cold atoms, that's fairly recent, the ability is there to exploit this stuff in practical products. From the knowledge transfer network point of view, we absolutely do not care. If there's something that can help industry create jobs and make money, then we're all for it. So we don't want to get bogged down on whether something is quantum 1.9 or 2.1. If it's a useful thing, we'll do it.
So from my perspective, I agree with a lot of the statements that my colleagues have said. I think it's anything that's based on the quantum physical situation of the way that you build a system. So on the one hand, when we talk about quantum technologies today, I totally agree that we're going to start off with hybrid systems. I totally agree that it's not necessarily clear what quantum technology exactly means. The word quantum is used far too often, not necessarily with the physics background. So it's anything based on what you've learned as physicists to build systems and what's behind that, and that's what you're basically trying to implement to build the computation, to build the communication, etc.
Can I comment?
Yep.
Okay, so thanks for the answers. So the definition I heard is quantum technology is a two persons, not on the panel offer the definition. Quantum technology is a technology that's based on quantum physics. I think, well, I mean, one can define whatever one wants, but then according to that definition, the transistor and the laser are quantum technologies as well, right? But then why are we saying that quantum technologies are coming up today and not like 70 years ago? So I think if we want to talk about quantum technology in the way people normally understand it as something new, not something that that's already happened, then we should define it differently. We should define quantum technology as our ability to manipulate complex, not necessarily complex, manipulate quantum systems at the level of their individual components, like particles, like atoms or photons or ions, right? And then we come to quantum cryptography, then we come to quantum computers, and so on. right? So I just think we should start with the definition before we do this test.
Yeah.
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 Sorry.
I sort of have a different view there in the sense that here we're talking about money that the government is in terms of the quantum technologies program. The government is investing money, a lot of money. It wants something back from that. In many of the things that we would call quantum technologies are really 10-year payoff systems, and it is extremely important for the field for us to find technologies which pad out that the next 10 years and get the industry started. Somebody said about sort of educating the Boeing or the British Aerospace into the existence of the quantum technologies and what their potential is, but bringing things in like photon counting, LiDAR as we're bidding into Innovate UK, or other things, and having little asides that say, and we're looking at superposition and entanglement schemes as well. But things that work now are not necessarily going to have superposition and entanglement in them.
Yeah. No, okay. And Chris, did I see you wanted to say something?
Well, sorry, it's not a question, it's a plug. Where's cohort 3? Hold up your hands, cohort 3. There we go. It sounds like everybody has a different definition. If you want to weigh in, they're doing a cohort project on what quantum in the home might look like, what the first devices you might use in your everyday lives are. So if you want to put in your favorite definition of what a quantum tech is, if you want to take a guess at what you think the first thing shows up in a home, we'll talk to the guys that had their hands up, and they've got a box at the back that you can submit your own views on. It sounds like for every person in the room there's two definitions.
Nicely timed there, Chris. Thank you. Okay, I think we've got about 5 more minutes, so there's time for one more question to put to the panel. Anyone else? Oh yeah, okay, let's go. No? Yeah, there's...
Okay.
Yeah, go ahead.
Yeah. So is there a single quantum technology that is actually bringing profit to any company?
Yes, people are building the building blocks for research. I think they're estimated to be, well, you probably know the figure, but there are over 1,000 research laboratories in the world. There is equipment being manufactured in the UK, things like cold atom traps that are being sold to research institutions. So yes, definitely people are making money out of it. Once we go beyond the building blocks, then there are probably early adopters such as some of the clocks. They are likely to be deployed as commercial products fairly soon. Different bits of exploitation of quantum technology is proceeding at very different rates. So things perhaps like the clocks, maybe the cold atom gravity sensors might be available quite quickly. We all know that the computing is much, much further off. You can already buy random number generators based on quantum physics techniques. That's already in the market right now. People are flogging that and making money out of it. Ironically, the biggest market is the gaming industry, but anyway, we don't mind. So yes, there's a big spectrum of timescales from stuff that's being sold right now to stuff that we reckon perhaps will be a quarter of a century away, I think.
The other thing I'd add to that is that money that is being made by some of the supply chain and some of the early startups is early adopter money. There's always a certain amount of early adopter money around globally, and they're doing well, but they're small organisations, some of them medium-sized ones. And it's the biggest problem is the next stage is crossing the chasm from the early adopters to the early majority, when significantly larger sums of money are required, and market sizes need to be large enough to satisfy those emerging markets. And we're nearly there. So I've been involved in AI for 30, 35 years and seen AI go through ups and downs through those. So we have to be wary of that. Let's look at other emerging tech like AI and other ones and see how they've managed to play this game. AI is in great shape now, but it hasn't been through the 30-year period.
I've only got one quick thing to say, and it's basically just to echo again what Bob has just said. At the moment, we're seeing people who are providing laboratories, providing early startup companies the equipment they need to set up their quantum technology. And I know for a fact that at the moment there's testing of quantum technologies going on at the moment, because if you're going to sell something which is said to have a lifetime of 3 years, you need to have it in your lab for 3 years to make sure that it's going to do that. So I believe over the next few years there's going to be a definite flourish of people earning money from actual early quantum technologies.
And so from my perspective, obviously, test and measurement company, we're happy to support all of the research going on around the world, and obviously there's some money to be made there with a more focused approach, as I mentioned in my presentation. And companies like ICE Oxford with their cryogenic fridges and technologies, if I look at it, we estimated that about 55% of, for instance, quantum computers or quantum computing research, about 55% are using cryogenic. And we have seen a very large increase, for instance, in cryogenic fridges over the last 3 to 5 years.
Okay, great. And I think that's about time, Brenna, unless Caroline.
Quickly.
Okay.
It is time, so I guess we'll say thank you to the panel.